A room does not change size when you photocopy it. An ordinary office machine, a Xerox work center, plans in, PDF out. One of the pages it scanned came back different, not damaged, not blurred, different. A number on the page had changed, and the machines had been doing it for about 8 years. Nobody noticed. How does a copier change a number without ever reading the page? Why would the cleanest scans be the ones that fail? And when the paper is gone, what do you check the file against? 24th of July, 2013. An office in Germany. A computer scientist named David Kriesel does something almost nobody does. He compares a scan of a set of construction plans against the paper it came from. One room label carries the wrong number. The paper says 22 square meters. The scan says 14. And the 14 is as clean as every character around it. Same typeface, same weight, same baseline. When a scanner fails, you expect noise, banding, a gray wash, a jam that shears off the bottom of the page. Damage announces itself, and that is the unspoken reason we trust the pages that come out looking fine. This was the opposite of noise. The machine had produced a tidier document that said something different from the original. The cause has nothing to do with the scanner's eye. The optics were fine. What went wrong happened after the picture was taken, in the part nobody thinks about, where the machine decides how to make the file smaller. A scanned page, stored honestly, is an enormous pile of dots. Every fiber of paper, every ragged edge where ink soaked outward. Nobody wants that file, so every scanner compresses. The compression at the center of this story is called JBIG2, built for black and white scanned text. It starts from an assumption that is genuinely clever. A page of text is not a random field of marks. It is a small number of shapes, repeated hundreds of times. Here is what it does to your page. 4 steps, and the story lives inside step 3. First, it cuts the page into small connected blobs of black, roughly 1 blob per character. Second, it compares those blobs against each other and sorts them into groups by how similar they look. Third, it keeps a single bitmap from each group and throws the rest away. That survivor goes into a dictionary at the front of the file. Every other blob in the group is now stored as 2 pieces of information only: which dictionary entry it is and where on the page it sits. Fourth, to show you the page, the decoder pastes that dictionary entry back at every recorded position. What comes back is not your page. It is your page's shapes, stamped from a template. Hold on to one thing about step 2. The machine is not reading. It never decided a mark was a 6. It has no alphabet, no language, no idea the page contains writing at all. It decided this patch of black was close enough to that patch of black, pixels against pixels, and a threshold. So, the failure is not a misreading, it is a mismatching, which is why the error looks the way it does. Read a character wrong, and you get a garbled character, and you can see it. Match a character wrong, and you get a perfect one. The bitmap it stamps over your 6 is a genuine 8, one that was standing correctly somewhere else on the same page and got promoted into the dictionary. It arrives fully formed, in your document's own typeface and your document's own ink. A copy and paste error at the scale of a single character committed by a machine that does not know characters exist. You have probably heard a version of this where the headline is a 6 turning into an 8. That framing runs through the 2013 coverage, and it is the cleanest illustration of what pattern matching does wrong. It is real. It is in Kriesel's own write-up, a 65 on one document that came back as an 85. But it is not the case he documented first. That was the room label. And in a story about numbers quietly changing shape, I want to keep the numbers themselves straight. 2 conditions made the matching worse. Small type, around 7 or 8 point, the size of the fine print at the bottom of a form. and a scan resolution near 200 dots per inch, a perfectly normal default. Shrink a glyph onto that grid and blow it back up, and a 6 and an 8 stop being obviously different objects. They become two nearly identical arrangements of dots, differing in one small region. To your eye at reading size, unmistakable. To a similarity score, a judgment call. There is a third condition, and it is the tell. This only happened on scans going straight to an image PDF, with text recognition off. Turn OCR on, and the machine stores recognized letters instead, which walks past the visual matching entirely. The machines that read your page were safe. The ones that merely photographed it were not. Kriesel wrote it up and published on the 2nd of August 2013. It moved fast. 4 days in, his own follow-up put the traffic at around 200,000 hits. Xerox's first public answer was that a patch would disable the highest compression mode. The implication, stated and repeated, was that at normal settings, you were fine. That did not survive further testing. Xerox went back, ran what it called stress documents, and admitted that character substitution was not eliminated at the factory default setting, or at the highest quality setting either. The company reassured everybody and then corrected itself in public, which is more than most manage. It also means the default was never actually safe. A Xerox principal engineer, Francis Tse, put the cause on the record as a combination of compression level and resolution setting. Not a manufacturing fault, not a bad batch, a trade-off living inside a standard. Then, on 12th of August, the number that gave this story its shape. Xerox confirmed to Kriesel that the bug had been sitting in shipped firmware for roughly 8 years, since around 2005. Get that straight, because it is easy to garble, and garbling it in a video about garbled documents would be a bad look. 8 years is not how long the scandal ran. The scandal ran about 3 weeks. Discovery on 24th of July, a published workaround on 6th of August. The patch pre-tested with Kriesel himself around 19th of August. First firmware patches out on 22nd of August. Once somebody named the problem, the fix took under a month. The 8 years is how long the machines did it in the open, in front of everybody, without anybody noticing. The affected list reads like a parts catalogue. Work Center models across 4 families, Work Center Pro, Color Cube. Press coverage put the installed base in the hundreds of thousands of units worldwide, an order of magnitude rather than a count. One detail I keep turning over. Kriesel refused money. He wrote afterwards that taking compensation from Xerox would have cost him the only thing that made him useful, which was having nothing to gain. By then, the story had stopped being about a copier. 2 years later, somebody wrote the technique out of the rules. Paper into a scanner, a file out the other side. Then the paper, on purpose, into a shredder. It is called replacement scanning, and from that moment, the scan is the record. Not a copy of the record. The record. The paper is gone because storing it costs money. What happens when a wrong number lands in the only copy left? Who checks a file against paper that no longer exists? And who decided that risk needed a rule written down? Germany has a technical guideline for exactly that, from the Federal Office for Information Security, the BSI. TR 03138, known as RESISCAN. By the BSI's own English summary, it covers administration, the judiciary, and private companies in healthcare, insurance, tax, and accounting. On 16th of March 2015, a revised version took effect carrying a new requirement, ASC 12. It bars compression based on pattern matching and substitution, the technique behind lossy JBig 2. It also bars soft pattern matching, the lossless variant, so the restriction is not aimed at data being thrown away, it is aimed at the matching itself, in both modes. And the German is not hedged. Dürfen nicht eingesetzt werden, must not be used. The stated reasoning, straight from the guideline's own annex, is that a pattern-matched scan can differ from the original in meaning through character transposition, and that even a correct implementation cannot give the legal certainty required. Read that back as a picture instead of a rule. Paper into a scanner, scan out, paper into a shredder, and the question the requirement is really asking, if the number in that file is wrong, what would you ever check it against? Now, the part where I have to be careful, because this is where the retellings slide. No documented case of real-world harm from this bug has surfaced. Not in the research behind this video, not anywhere I could find. No lawsuit, no collapsed structure, no wrong dose administered. Kriesel himself raised medical dosages and structural dimensions as things that could go badly, and those were warnings about a category, not incidents he was reporting. His own construction plans remain the only documented instance in the wild, and he caught it himself before it cost anybody anything. An error you can see gets found. An error that looks like a correct result gets filed. So the honest statement is not that people were harmed. It is that a failure with no visible symptom, running for 8 years inside the machines that handle the documents nobody keeps duplicates of, leaves no way to find out either way. The guideline is still live. TR 03138 went to version 1.5 in November 2024, adding rules for scanning with phones, and the pattern matching clause came through that revision, word for word, unchanged. 11 years on, the restriction is still on the books, and Xerox's own support article documenting the fix is still on their site today. The machines got patched. That part is genuinely finished, and I do not want to leave you standing over the office copier tonight. What the story leaves behind is not a warning. It is a correction to how the object works. A scan is not a photograph of a page. I had always assumed it basically was, the way you assume a mirror is showing you the room. It is a reconstruction. Somewhere between the glass and the file, something sorted your document's marks into groups by resemblance, kept one specimen out of each group, discarded the others, and rebuilt the page from what it kept. Most of the time that is fine, better than fine. It is why the file is small enough to email, and why the page it hands back is often cleaner than the paper you fed it. That cleanliness is the product working. It is also the problem. Every failure we ever learned to distrust in a document was a visible one. Toner streaks, a crease through the middle, the photocopy of a photocopy of a photocopy, fading until it is basically a rumor. You could see the damage, so you knew to go back to the original. A pasted glyph has no tell. It is arguably in better condition than the character it replaced, because the real one carried ink spread and paper grain, and the pasted one is a clean specimen. The wrong number is the sharpest thing on the page. Open your downloads folder sometime. Payslips, a lease, a form from a clinic, an invoice that came out of somebody else's copier in an office you have never been to, on settings you will never know. I have never compared any of mine against the paper, and for most of them there is no paper left. And the shape of it has not gone anywhere. A pattern matcher that fills in what it decided was probably there and hands back something confident, well-formed, and indistinguishable from a correct answer is not a 2013 copier anymore. It is most of the document pipeline now. Text recognition over scanned archives, automatic transcription, systems that read a form so you do not have to. The copier was never lying. It was doing precisely the job it was built to do. Notice that 2 shapes look the same and keep only one of them. The error was ours, and it happened upstream of the machine. We looked at a scan and thought we were looking at a picture, so run it back. The payslip, the lease, the form from the clinic. How many of them were rebuilt by a matcher that never knew it was looking at numbers? What paper would you check them against, now that the paper is gone? And if one digit gave way in the document's own ink, would anything on the page look wrong? You already know. 22 became 14. Nothing looked wrong. That is the part to keep.